Mount St. Helens, a Washington state volcano, has been dormant for over a century, but today it erupted with smoke and ash after a week of earthquakes which rattled the area. The volcano oozed lava and belched an explosion that was heard up to 45 miles away. The blast took place about 1 o'clock this afternoon. It was the first volcanic eruption in this country since 1914.
This eruption had unusual amounts of argon in it. Well, that throws off all of the assumptions in your dating methods. It just brings attention to the fact that these dating methods are assumption laden. You're not measuring age, you're interpreting age.
Welcome to the Creation Today show, where we bring together interviews with experts and solid Bible teaching. Your host, Eric Hovind, affirms the ultimate authority of God's Word, the truth of creation, and why it matters to you.
Well, guys, we are coming up on the anniversary of the Mount St. Helens eruption that literally changed geology and was a gift, God's gift to creation scientists around the world, giving us modern-day evidence regarding the formation of many worldwide geological phenomenons that we see today. It was May 18th, 1980, that this destruction left, it left a mountain of evidence for us to dig through. The observable, recorded facts revealing the actual formation indicate what really happened around the world. This truly is God's gift to creation science. We titled this show, Mount St. Helens. This is literally how Mount St. Helens rescued creation scientists. My name is Eric Hovind. I'm your host. I'm joined by Bill Hoesch, who has a lot of experience in geology, in research and education, oil and gas exploration. He's now the director of the Mount St. Helens Creation Center, and I'm really excited to have him on because his backyard and his whole ministry right now is centered around Mount St. Helens. Bill, welcome to the Creation Today show, buddy.
Well, thank you, Eric. It's a pleasure to be with you. Nice to see you.
I am so thankful for what you do and what you have done. I cannot wait to hear I know some of the things, but you lived out some of the things that happened at Mount St. Helens and the research that was done shortly after Mount St. Helens. And so I'm really excited to kind of get an overview of Mount St. Helens and how it's rescued creation science. Now, am I going a little too far there? I mean, I've been there many times and I'm like, is my title a little bit too strong? Or is it like, no, this gave us a modern day geological landscape to confirm the global flood? Tell me, am I too strong on that or not?
Eric, I think you're dead on. First of all, I'd like to give thanks to Dr. Steve Austin, who's the one, more than anyone else, who brought attention to Mount St. Helens as something that's of great importance to anybody who's thinking about biblical geology. And, I'm just a geologist, but no, I think you're dead on St. Helens. And a lot of people, like the public visitor centers near us, they like to sweep right past that. They like to water down the catastrophic nature about number one. Number two, it's the thing that is exciting to geologists. It ought to be, at least.
You've been there now I met you there last year. By the way, Creation Partners, those for the second half of the show, I've got a surprise for Mr. Bill and a surprise for you. I want to show you something that we worked on together quite a while ago and just give you a little sneak peek, a little preview of something we're working on. But you've been there for how many years now at Mount St. Helens Creation Research Center?
About 3 years.
3 years now.
Yeah.
And it really is incredible what you guys have inside of there. And all the evidence is literally laid out. And people can come visit your center right there and get all the facts about Mount St. Helens. And are you guys already doing your tours to Mount St. Helens?
Yeah, we just started. We did our first tour last Saturday. The snow is away, and we did it. We're going again on May 18th to celebrate the eruption.
Wow. If you guys ever want to go on a tour of Mount St. Helens, you got to visit the Mount St. Helens Creation Center there and let Bill take you on a tour because you're going to see it like no other. We're going to do the best we can via Zoom here or online to show you some of the things about Mount St. Helens. But if you ever get to go there and actually do the hikes and go up to the visitor center, it truly is remarkable. All right, Bill, where should we start? How many, I was trying to think through how many different areas of research did Mount St. Helens help us with? And everything from ecology to how fast does the stuff come back to geology to physics, the physics of pyroclastic flows. I mean, there's so many areas that it helped us in. Where do you want to get started in teaching us how Mount St. Helens really rescued creation science?
I think one of the first places to begin would be isotopic age dating. How did they, when they dated rock that had formed since 1980, did it give numbers that were 10 years or less in age? No. The rock's age was actually 6 years old, and it gave numbers of upwards of 350,000 years all the way up to 2.8 million, indicating what? Well, this eruption had unusual amounts of argon in it. Well, that throws off all of the assumptions in your dating methods. It challenges to the core. It just brings attention to the fact that these dating methods are assumption laden. You're not measuring age, you're interpreting age. And the numbers that you get are only as good as the assumptions that go into it. You can't measure the age of rock. No scientist can do that. You can measure rock's mass, its density, its temperature, measure all kinds of stuff about a rock. You're not going to measure its age. You can interpret it, but your interpretation is no better than the assumptions that go into it. And the geologists that I talk to, they say, well, come on, Bill, it's the best guess we've got. Why don't you go with it? I got no problem calling it guesswork because everybody knows that's what it really is. But when they teach school children that they're able to measure the Earth's age at about 4.5 billion years based on this very same authority as the rock dating in Mount St. Helens, I say that's child abuse. I think it's wrong, and I think it's really evil, that we're teaching something that's not true.
Wow,
and as
how ironic.
As a geologist, I can say that because and every PhD geologist knows it's true that you're not measuring age, you're interpreting it. There's a fundamental difference there.
That is powerful. How ironic that now the secularists are saying you creationists are the ones abusing children. And the reality is they know they're the ones lying to kids because you cannot get an absolute date. Can we back up and go, okay, give me the overview of radiometric dating then for somebody who wouldn't understand that, because most people know carbon-14 and there's many different radiometric dating methods. Can you give a quick overview of what you're talking about there so that if somebody doesn't know, it'll make a little bit more sense that, look, we found this rock, we know how old it is, and the radiometric dating did not work?
Yeah. So the long half isotopes are the ones you want to look at. It's very different from the carbon-14 method. We can put that aside for now. So if I want to date a rock, and if it's the right kind of rock, in other words, it was once a molten and igneous rock, what do? I take that rock, I send it to the lab. I say, lab, I want you to measure 2 isotopes in there for me. Let's say you measure the amount of potassium, the amount of argon in the rock, right? And you give them a lot of money, right? Usually it costs money, right? You give them a lot of money and they make those measurements. And then the geologist interprets the actual measurements and says, well, since we know that, the decay of potassium has gone tick, 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 tick at the steady rate for ever since the beginning, right? And since we know there was no argon at the beginning of the decay process, and since we know that nothing is leaked in or out of the system, therefore the rock is up to millions of years old. That's the way the dating method is used. And you can talk till the cows come home, but there's no way you can test those assumptions. Those assumptions are just assumptions, and they're made on the basis of a false philosophy that you can project present rates into the past, which is exactly what the Apostle Peter warned us about 2,000 years ago. This has only happened in the last 200 years or so, since people have claimed that they can measure the age of the earth. That's in conflict with what the Bible teaches. It's a Johnny-come-lately on the scene of church history.
Interesting. So they're trying to measure the rates of decay and tell you how old something is.
Well,
And
the rate of
you
decay is
actually,
measured. That's objective measurement. The rate of
okay.
decay is something you measure, and the amount of isotopes in the rock are things you measure, and then you begin interpreting from there.
And you were actually part of the team that did, you guys were measuring the rate, RATE, the rate of what was actually happening. And is it, are there things throwing it off? What do we have today? Can you tell me about the rate project that you were a part of?
Oh yeah, yeah. So I was my role in the project was I was a lab helper to Dr. Steve Austin, and so I did some of the mineral separations where you're separating Grand Canyon. I was working primarily with a Grand Canyon rock called the Bass Rapids Diabase. And ordinarily, geologists, when they date a rock, you obtain one date because it's an expensive, it's an ordeal, it's a big project to get one date. In this case, we said, what's going to happen if we raise support for this project to apply 4 different independent dating methods to the same rock? In other words, 4 different independent isotope pairs. And so we got ages for this one rock, a Precambrian rock claimed to be very ancient, ages on the order of everything between 845 million to about 1367 million, depending on which method you use. And the problem is that the error bars, they don't even overlap. In other words, they're truly contradictory. And like Mount St. Helens, we just see another example of contradictory age dates. And so what does the scientific community do with this? Well, they begin to rationalize and they say, well, the numbers at we can reject the potassium argon date and we'll go in favor of the samarium neodymium date, et cetera, et cetera. And there's this rationalization that goes on. In other words, they arrive at the date that fits their model that they prefer to begin with. And that's the problem with this, is there's just a little too much picking and choosing that goes on in the dating methods. And so I object to that, and I say there's no way you can reject the data from one date and embrace the other, right? It's done completely arbitrarily, and in other words, it's something other than science. It's not scientific. A scientist ought to question this if he's thinking straight.
So if I understand that correctly, you're saying you guys dated four different types of elements. So you got your uranium lead, you got your potassium argon, and from what I understand, there's like 30 different ones. Is that right? About 30 different ways to do that?
Well, maybe not 30, but there's a lot of different ways. Yeah.
Okay.
And it's all
I've heard the number 30. But that includes radiocarbon and carbon 12, carbon 14, all these different. And basically, if you're not familiar with this, this is an isotope that is unstable, that has it's an extra electron or an extra proton. Do you remember?
Yeah, it's in the nucleus, so it's not involving electrons or really protons, but it's primarily in the nucleus. So it's independent. The nuclear decay is decaying tick, tick, tick at a steady rate as far as we can measure today. But the problem is, can you assume it's been steady in the past? And the answer is absolutely not. You can't. There's no basis for saying from science that we can assume that the dates have always been constant, or the rates of decay have always been constant. We don't know that, and it's a funny world that we live in.
And now that is interesting, because if you talk to a statistician and you say, can I extrapolate this data? How far out can I go with this amount of data? They'll give you a range of how far you can extrapolate. And when we've been looking in the lab at the decay rates, which is basically going as forgive me, I was thinking electron or proton, but it's actually in the nucleus. As that nucleus decays and goes from one element, from an unstable element to a stable element, so uranium turns into lead, right? Potassium turns into argon, and there's multiple of these. And we can tell how long that takes per atom to do that, or the rate of decay. But we can't, we've only measured that for a limited amount of time, and then we're extrapolating for billions of years. And a statistician would say, hold the phone. You don't have enough data to go back that far in time. Is that a kind of a correct way of saying that?
It is extreme extrapolation. You're exactly right. It's like using a yardstick to, to measure the length, of the universe or something like that. It's that extreme. It really is.
Wow.
You need a longer yardstick, really, if you're going to be honest.
Yeah,
And
it's
so,
like seeing a car for 0.5 seconds and going, look, during that 0.5 seconds, it was going 60 miles an hour. And therefore, it must have left California, 12 days ago. That's kind of the extrapolation that we're doing with the radiometric dating of what we've
right.
studied.
Or you can put it this way. I've heard it put this way that let's say if I really, really try hard, I might be able to run a mile in under 10 minutes now, right? Uh, but if I try harder, I might get it down to 9 minutes after another month of hard training. And then I might get it down to 8 minutes if I really worked at it for another couple months. Uh, does that mean I can extrapolate that rate of improvement backwards in time and I'll eventually be, you know, cover a mile in a minute or something like that? No, you cannot extrapolate things like that, you see. And so that's I've heard you use that picture. So yeah, there's no way to test these things.
Okay, so your rate project, which you guys took these samples and had them dated 4 different types of radioactive decay dating methods done. So we have same rock, and you did, let's say potassium argon. Then you did another one, uranium lead. You're saying the dates for this, if I were to write the date range on this from 350 million up to 380 million, or I guess you were at 800 and something million, the date ranges did not even overlap. The timing didn't even overlap
Right.
on these 4 different methods.
Yeah. Yeah. So they're truly contradictory. Yeah. And so, you got 4 different methods: potassium argon, rubidium strontium, lead, and samarium neodymium. All of them gave different numbers. And so you have to ask yourself, what's the real story? Do we take an average of them and we call that the truth? Uh, or at what point do you begin to ask the question, maybe they're not telling us anything at all? Maybe it's something quite different that we're measuring besides age. It could be that lots of different problems, lots of different things. We shouldn't seize on this, that this is necessarily an indicator of age. As a scientist, I think that's what we should be saying. Yeah.
And that's what Mount St. Helens did for you guys, right? That's when you guys did the dating of Mount St. Helens rocks, you were like, we got something here, guys. Bingo. We're on to a major flaw in your system.
Well, Mount St. Helens is just a flag like many others. And there's several other, I mean, there's dozens of potassium argon age dates that are completely wrong. It seems like most historic volcanoes are 100 years or 200 years old, ones that happened in history. They always seem to give inflated potassium argon age dates. Well, why is that? Well, obviously there was excess argon in those eruptive products. Well, how do you know there was not also excess argon in your ancient unknown rocks where you don't have an absolute age check for? How do you know they also didn't have that same problem? There's no way to test that, you say. It's guesswork.
Timothy on here says, I wish I had a science brain. I'm getting lost too easy. So Timothy, let me, because this is powerful. This is powerful stuff. So Mount St. Helens, and I got a surprise for you because you're one of our partners. I got a surprise for you in the second half of this show. So basically Mount St. Helens erupts. They have brand new lava that is now formed in the dome of Mount St. Helens. And I think, was it 12 years or 10 years after the eruption is when you guys got permission to go down in the dome now and actually break off pieces of this brand new lava and go get it tested. Is that right?
Yeah, approximately that. I was not part of the team that went in there, but
Okay.
Steve Austin got permission to go in there and sample it, and he followed the rigorous procedure in everything he did, and it would pass muster in any scientific journal. Then he objectively dated the rock, and you got this completely nonsense answer, preposterous answer, that you have to say, what's going on here, and it just raises attention to the issue that these assumptions are not testable by science. You're making a guess. about things. It's an educated guess. And, I'm not going to say there's no consistency with radioisotope age dates in general. You get a certain amount of consistency, but you also get way too many contradictions, way too many. Uh, and
Very
so I think
interesting.
anybody ought to question this. If you're interested in truth, that ought to be your question.
That is a great way to put it. So this new lava is formed. They go up, pick some of this lava, and date it. And if you use the potassium argon dating, they're testing how much potassium has decayed into argon. And there's way too much argon, and it makes it look old. And so the dates you said for the 10 to 12-year-old lava up there was 350,000 to 2 million years old, somewhere in there.
Yeah, between 350,000 and 2.8 million, depending on whether you do individual mineral phases or the whole rock. You get a large variance, just a large
Wow.
variance in you. And that's a perfect rock for dating. It should be straightforward.
Now, that's the other thing I was going to ask is when it goes from magma to lava, that kind of resets the isotope clock, or it's supposed to reset the isotope clock, correct?
Right. Yeah. So the age that you're dating is the age of crystallization, when it went from a liquid to a solid phase. That's the age of that you're after, and that's when you begin trapping the daughter product in the mineral lattice. So you have to trap that daughter product in there, and so the argon is not going to, theoretically at least, is not supposed to accumulate or become trapped in a liquid phase, because it just boils out, uh, because it's a noble gas. It doesn't want to stick around. But after the mineral lattice is in place, then the argon begins to accumulate, theoretically.
Wow. Yeah, so
Except in,
theoretically, yeah. So
yeah,
theoretically, as in the liquid flowing out of the Mount St. Helens, the argon is just boiling off. It can't exist. It solidifies into lava, and now it can actually trap the argon. Now we can go see how much
yeah,
potassium is decayed into argon,
right.
and we're getting these wild dates.
And it's that way with all the isotope pairs. The rubidium strontium operates the same way. Neodymium samarium. There, you're not dealing necessarily with a gas phase, but there's the argument is made that at the point of crystallization is the point where you begin to accumulate that daughter product that you're after. Yeah.
Very interesting.
And so there's
In
three
just
of
a second, I'm going to have to let social media go here in just a second, but do you have a list? Okay, so we got radiometric dating. That really, Mount St. Helens was a huge rescuing help for creationists when it comes to radiometric dating, because we watched it, we got pictures, we got video of this thing forming, and here's how wrong they are on the dates. Are there any other things that Mount St. Helens did for creation scientists in general that helped us, I don't know, rescue creation science, made people realize, look, this catastrophe shows us the catastrophes around the world are evidence of the flood?
Yeah, I'd like to invite all your guests. Come on out to our creation center. This is a happening place. We got some of the best information on Mount St. Helens of any of the public visitor centers. I just want to get that in. Is there anything else? Absolutely. Rapid formation of layering and pyroclastic flows. You wouldn't expect a pyroclastic flow to produce neatly layered deposits, but it did at Mount St. Helens. You wouldn't expect large canyons to form rapidly from moving mud and not slow and gradual erosion over millions of years. You wouldn't expect to get this extraordinary event where you have this floating log mat of trees, and the trees settle vertically, mimicking an ancient forest that grew on the bottom of the mud, because they settled on the bottom of Spirit Lake. There's 20,000 trees standing vertically that never grew there. It's extreme. And it makes us question other so-called fossil forests around the world. And then there's also the origin of coal, which was really a fascinating story. The tree bark that settled off on the bottom from those trees that settled to the bottom, mimicking a perfect scenario for the origin of coal. And then the rapid regrowth that they were saying it's going to take 200 years for this forest to come back, and it's well on its way today because of what? Unforeseen things that happen in the realm of biology. And it makes us wonder about how the Earth recovered from a global flood in Earth history.
So it's rescued creation science in biology and geology and physics and so many other areas. What a lab, a big giant lab to work in there at Mount St. Helens. Hey, if you guys want to go visit, you got to get a hold of the Mount St. Helens Creation Center, and their website is just MSH. So Mount St. Helens, mshcreationcenter.org, mshcreationcenter.org. And please go by there, say hey to Bill, and let Bill take you on a tour. Go visit his creation center and let him take you on a tour of the mountain. You guys try to stay open all the way till, is it September, October, somewhere in there?
Yeah, we do our field adventures between middle of May and middle of October.
October, yeah.
And yeah, but we're open 9 to 5 Monday through Saturday. We get visitors year round. And
I love it.
It's a good visit here. Yeah.
Definitely good. And man, some of the displays you guys have, some of those rooms, the dinosaur, oh man, you guys got to go check out Mount St. Helens Creation Center, okay, with Bill Hoesch and hang out there. Tell him Eric says hi when you go see him, okay? Hey, social media, I got to let you go. I cannot wait. I want to read you something that I wrote, and I'm like, okay, I'll see how this goes. This may not go well. I'll read you something that I wrote to close this out. But next week, guys, I've got a great show. We're going to be talking about biblical slavery. Is it justified? Does the Bible justify slavery with Vocab Malone? You're not going to want to miss that. We're going to be live here at noon next Wednesday. So please join us next Wednesday at noon and make sure you're ready for this. That's going to be an interesting conversation. Your skeptic friends that like to use slavery to try to make fun of the Bible, they're not going to be happy with the truth. So if you like to say that, oh, well, the Bible justifies slavery, therefore I don't believe the Bible. If you like that argument, even though it's a bad argument, don't listen next week, okay? Because we are going to blow that one away. All right, Bill. So I gotta let social media go, but let me try my hand at my poem. This is my first real delivery of this poem. We'll see how it goes and see what you think, and then I'll let social media go. In 1980, Mount St. Helens blew, showed us what a volcano could do. In a few short hours, layers formed quick, not millions of years. That's an old school trick. Mount St. Helens, boom, boom, bang, evidence for Noah, let that truth hang. Catastrophic processes changed things fast, proving the flood happened in the past. Sediment layers stacked up in 3 hours, fine and neat, showed Earth's powers. A pyroclastic flow and ash in the air, geologic features forming everywhere. Canyons don't take millions of years. Time for geologists to tell their peers. Little Grand Canyon formed in just one day. Let's speak the truth before we pay. Logs floating, tipping, standing tall. In Spirit Lake, they showed us all. It was one big flood. That's the event. It put all those trees into the sediment. Radioactive dating, yeah, it's flawed. Mount St. Helens proved, and we applaud. A rock formed quickly but dates millions of years? Now we know the truth. It's crystal clear. Mount St. Helens showed us what's the deal. The biblical flood, man, that's for real. Geologic features, fast and grand, proving the flood by God's own hand. That's the truth of Mount St. Helens. Guys, thanks for joining me on social media. Please check out everything Bill has at mshcreationcenter.com, Mount St. Helens Creation Center, and go visit him. You're going to love it. If you want to join me for the rest of the show and the sneak peek of some stuff I'm going to show the Creation Today partners, come on over to creationtoday.org. Partner with us. Help us get the gospel out around the world, and you can watch everything we've ever done and be part of our live events right here behind the scenes at Creation Today. Can't wait to see you guys next week.